Today we will try to connect our concepts and algorithm with pure mathematics. This is an algorithm to find the biggest of n elements in an array. First element match equal to a of 1. Then we will be comparing this maximum element with the remaining elements, and finally it will be returning the maximum element. We have to analyze this algorithm independent of omissions and independent of languages. For that, we are assuming that the time to execute this statement is some C1 nanoseconds. We are not at all interested in the exact time required to execute max equal to A1 in any machine. Okay. And here inside the for loop we can see I equal to initialization, then comparison, then increment. Initialization works only once. After that it will be compare. Then if the conditions true, statement will be executed. Then for the next iteration it will be incrementing, then comparing. If the comparison is okay, it will be executing the statement. So we are assuming for the working of for loop, it has to increment and compare. It works many times. Let us assume the execution of these statements one time it will take some C2 nanoseconds, or the cost is C2. Okay. Then cost for execution of this statement is C3, and cost of execution of this is C4, and cost of execution is C5. Okay. And we know this statement will work only once, and this statement the loop will be breaking when I equal to n plus 1. That is, I will be varying from 2 to n plus 1. 2 to n plus 1, there are n items. So these statements, this I less than or equal to n, this statement will work n time. Okay, here we are doing some asymptotic analysis, so we are not considering the minute details. Okay. Here, since this for loop work n time, this will be working n minus 1 time, and this will be working n minus 1 time, and this will be working once. So the total execution time of this algorithm, or time to process a problem of size n, is equal to time taken by all the statements. Okay, this will be working only once. It requires time C1, so 1 into C1 plus this work n times. It will take C2 time to work once, so n into C2 plus n minus 1 into C3 plus n minus 1 into C4 plus C5. We rearrange the terms. I will be getting n into C2 plus C3 plus C4 plus C1 minus C1 minus C3 minus C4 plus C5. Now this in the form some constant a into n plus some constant b. Okay, so the execution time of this algorithm is in the form an plus b. Okay, next let us consider an equation or a function of the same form an plus b. Let us say some f of x equal to 10n plus 20. Okay, sorry, not f of x, let's say it is f of n. F of n equal to 10 plus 20. Here let us follow this asymptotic analysis. We will say when n becomes very large, we can avoid or neglect these constants 20 and 10. That means when n becomes some infinity or very large, the contribution to the value of this function f of n by 10 and 20 can be neglected. Means their contribution will be very very small. And we can say f of n equal to n. We know 10n plus 20 not equal to n. But we are saying our f of n, that is 10n plus 20, is asymptotically equal to n. Okay. We never say f of n equal to n. We are saying f of n is asymptotically equal to n. Okay, in asymptotic analysis we avoid or we neglect minor details, and we will consider only the terms which will contribute more or whose contribution is significant. We will consider only those terms. Okay. Next we need some notations. For this asymptotic analysis. So how can we say this? How can we represent f of n is asymptotically equal to n? So we need some notations. For that, let us consider a function, some 11n. Okay, some function 11n. In general, let us consider a function g of n equal to some n and a positive constant c. We will get c into g of n is equal to 11. Okay, so we have f of n and c into g of n. Let us plot this for the values of n, f of n and c into g of n. When n equal to 1, f of n is equal to 30 and c into g of n will be 11. When this is 10, it will be 120 f of n. C into g of n will be 110. When this becomes 20, f of n will be 220 and c into g of n 220. When 30, this will become 320 and c into g of n 330. When it becomes n becomes 40, this will be 420 and this will become 440. Okay, we can see that this 11n equal to f of n when n equal to 20. After that, for any value of n greater than this 20, value of f, c into g of n is greater than f of n. We can say f of n is less than or equal to c into g of n for all values of n greater than or equal to 20. Okay. Let us draw a graph. This will be your 10n plus 20 and this will be your 11n. This point will be 20. Okay. This c into g of n, that is 11n, is always greater than or equal to 10n plus 20 for all values of n greater than or equal to 20. So beyond this 20, 11n is always greater than 10n plus 20. So this way it is f of n or g of n. Okay, so we have a function gn such that C into G of n is always greater than or equal to f of n for all values of n greater than some n0. Okay, in our case this n0 is 20. Okay, we have f of x is always less than or equal to C into G of n for all values of n greater than or equal to n0, where n0 and C are positive constants. If this satisfies, we can say f of n is of order big O G of n. That is, if there exist some positive constants C and n0 such that f of x is always less than or equal to C into G of n for all n greater than or equal to n0, then we can say f of x is of order G of n. Okay, that is 10n plus 20 is of order big O, or G of n is n, big O n. 10n plus 20 is big O n. That is when n becomes very very large, 10n plus 20 will become n. Okay. Here we have similar way. Okay, this is in the form an plus b. See our Tn equation, that is time execution time of the algorithm. It is an plus b. We can say this execution time of algorithm, it is big O n. It is an plus b same. So we can find some function g of n such that f of n is always less than or equal to c into g of n for some positive constants n0 and c. Okay, so here we can say Tn is of order big O n. So this way we can relate our algorithm concepts and pure mathematics. And remember in the previous class I have told you can draw so many lines above this 10n plus 20. Okay, one is 11n, then another one is some 20n, 30n, 100n, 200n. Okay, for different c values, and you will be getting various n0s. So you are getting a group of functions, isn't it? So this big O n is a family of functions, and we are saying that 10n plus 20 belongs to that family or belongs to that group. So this is the concept of big O. N, then this is your f of n, c into g of n, this is your n0. Okay, this is the concept of big O. F of n is always less than or equal to c into g of n for all values of n greater than or equal to n0. C and n0 are positive constants. This is the concept of big O. Here we can say this Tn is of order big O n, or your algorithm is of order big O n. This way you can relate your algorithm concepts and mathematics.